Alright, in today's video we're looking at the first worksheet in the stoichiometry booklet. It's entitled Acetaminophen, which of course is the active ingredient in Tylenol pain relief. We're given here a picture of a molecule of acetaminophen. We can see it's molecular because it's made of just non-metal elements, so it's a covalent compound. We're going to write the chemical formula for acetaminophen, and when we do that, we put the elements in the order carbon, hydrogen, oxygen, and then if there is some nitrogen, and if there's any other elements, they would follow those. So when you write the formula, put the elements in that order, Chon. So in this example, let's count the number of carbon atoms. We have 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. So we can say C8, subscript 8. Next, we'll put the hydrogens, count the hydrogens, and we get 1, 2, 3, 4, 5, 6, and then there's 3 more here. So that's 9. So C8H9. And then oxygens, we can see 2 oxygens, so O2, and there's 1 nitrogen atom. So C8H9O2N is the molecular formula for acetaminophen. Next, we want to calculate the molar mass. Molar mass is the mass of 1 mole, right? That's what that means. If you haven't learned about the mole yet, you'll want to watch the video that precedes this one that describes the concept of the mole, which is one of the most important ideas in chemistry. So the molar mass of acetaminophen is the mass of 1 mole of acetaminophen. To do that, we take the molecular formula and we break it up. We have 8 carbon atoms. You go to a periodic table and you find carbon. Okay, if you haven't got a periodic table beside you, pause the video and get one. When you look at carbon's symbol on the periodic table, you'll see the number 12.01 or something like that. You can round it off to 2 decimal places. Up till now, we've said that that was the mass of 1 atom of carbon, and we described it in units called atomic mass units. So we would have said 1 atom of carbon has a mass of 12.01 AMUs on average, based on all the isotopes of carbon. Now, instead of looking at it as the mass of an atom in AMUs, we're going to look at it as the mass of a mole of carbon. So that's going to be called the molar mass of carbon. And it's not measured in AMUs anymore, it's measured in grams. And the explanation for how that works is in the first video on the mole. If you haven't watched that, go watch that. So 8 carbons means we have 8 moles of carbon in a mole of acetaminophen. So we'll say 8 times 12.01 grams. That gives me 96.08 grams of carbon in every mole of acetaminophen. We have 9 moles of hydrogen in every mole of acetaminophen. So it's going to give me 9 times from my periodic table, find hydrogen and get its molar mass, 1.01 grams. So 9.09 grams of hydrogen are in 1 mole of acetaminophen. In 1 mole of acetaminophen, there are 2 moles of oxygen, O2. So we'll say 2 oxygens, 2 times oxygen's molar mass on periodic table, 16.00. So there's 32.00 grams of oxygen in every mole of acetaminophen. And then we have 1 mole of nitrogen in every mole of acetaminophen. So that gives me 1 times 14.01 grams, the molar mass of nitrogen from a periodic table. That's 14.01 grams of nitrogen in every mole of acetaminophen. Add these numbers up and you'll get the molar mass of acetaminophen, 151.18 grams. This is the molar mass, the mass of 1 mole of acetaminophen. The percent composition of acetaminophen, since I've shown my work for finding molar mass, this is going to be pretty straightforward. Let's first find the percentage of carbon in acetaminophen. To say the percent composition means the percentage of each element. So I'll do carbon. From up above, we can see we have 96.08 grams of carbon. And the molar mass, the total mass, was 151.18 grams. And we times by 100 to get a percentage. So that's going to be 63.55, keeping 4 significant digits, according to our significant digits rules, percent carbon. I'll do one more, and then I'll leave the rest for you to do. The percent hydrogen. From up above, there's 9.09 grams of hydrogen out of a total of 151.18 grams, the molar mass, times 100. This time we can only keep 3 significant digits in the answer, so 6.01% hydrogen. So you do the same thing. You can find the percent oxygen, and you can find the percent nitrogen in the same way. When you've done all of the percentages and add them up, you should find that the answer is very close to 100%. You may have a 99.99 or 100.01 because of rounding issues, but it should add up to approximately 100%. Question D. This is now getting into basic stoichiometry calculations. The word stoichiometry just means using ratios. And right now we're using the ratios in a chemical formula. So this is a formula stoichiometry. So we have 0.0250 moles of acetaminophen. I'll just write ACET for acetaminophen. You can write its formula if you like. We want to know what mass that is. Well, mass, of course, is measured in grams. So we need to set up a unit multiplier. This is where the ratio comes in. We're going to get rid of the moles of acetaminophen, and we'd like to convert that to grams of acetaminophen. Well, here we need a recipe. Well, the recipe is the molar mass. Remember that 1 mole of acetaminophen, that's the molar mass means 1 mole weighs 151.18 grams. So we can come back down here and use that as our unit multiplier. 1 mole of acetaminophen weighs 151.18 grams. You might want to remind yourself when you see moles and grams of the same substance in a unit multiplier, that is your molar mass. So we're using the molar mass that we calculated earlier. Significant digits, I can keep 3 digits in this answer. So we get on a calculator 3.78 grams of acetaminophen. Okay. Question E, how many molecules of acetaminophen are present in 25 grams, 25.0 grams? Just stop and think about that for a minute. If you had a 25-gram sample of acetaminophen, that's a lot of acetaminophen, you'd think about how much is in a 1 tablet of Tylenol has probably about half a gram. So if you've got 25 grams, that's like 50 tablets of Tylenol. How many molecules of acetaminophen are going to be in there? Well, molecules are incredibly small, so there will be an incredibly large number. I'm expecting here to get a huge number of molecules as my answer. Well, how do I find the answer? Well, we'll take the number that was given. We have 25 grams of acetaminophen. And what we'll do first is what we did sort of up above. Before, in the last question, we converted moles to grams. This time, let's convert grams to moles. So we will get rid of our grams of acetaminophen, and we'll switch that to moles of acetaminophen. Using, just like up above, this will be the molar mass, right? When you see moles and grams together like that, that's the molar mass. 1 mole weighed 151.18 grams. Now, why are we finding moles? the question asked for molecules. Well, you remember the definition of the mole told us that in 1 mole of anything, in this case 1 mole of acetaminophen, there would be that huge number, Avogadro's number, of things. So since acetaminophen is made of molecules, right? It's that formula on the front, it's made up of molecules. 1 mole of acetaminophen would have 6.022 times 10 to the power of 23. That's Avogadro's number. Avogadro's number. And the answer here will be molecules, because acetaminophen is made of molecules. So on my calculator, I can keep 3 significant digits. 25.0 has 3 digits. And when I type that in on my calculator, dividing by the molar mass and multiplying by Avogadro's number, pause the video and see if you can get this yourself. You should have got 9.96 times 10 to the power of 22 molecules of acetaminophen. Alright, so just think again about what we did here. To find the molecules of acetaminophen, we first needed the moles of acetaminophen, because then we could use the fact that 1 mole has Avogadro's number of molecules. To get the moles of acetaminophen from the mass, we used the molar mass. So we did that using 2 unit multipliers. Part F is going to get a little bit more complicated. Part F is going to require 3 unit multipliers. We have 1.523 grams of acetaminophen. Let's think about what we could do with that. I'm not even going to read the rest of the question. If I know the mass, then I know the molar mass also, so I could convert this to moles if I wanted to. Then if I wanted to, I could take the moles, and like we did in the last question, we could use Avogadro's number and we could find the molecules of acetaminophen that are in that sample. So in my head, I know I can do both of those things. Now the question is not asking for the moles of acetaminophen. It's not asking for the molecules of acetaminophen. It's asking for the number of oxygen atoms that are in that sample. Well, looking back at the chemical formula and the chemical structure of acetaminophen, you remember that in any 1 molecule of acetaminophen, there's the molecule shown there, there were 2 oxygen atoms. So you say that again, in 1 molecule of acetaminophen, there are 2 oxygen atoms. And as soon as you say that, you realize that's a unit multiplier. 1 molecule of acetaminophen has 2 atoms of oxygen. So if I knew the molecules of acetaminophen, then with 1 more multiplier, I can convert that to atoms of oxygen. So let's set this up the same way that we did the last one, and then we'll add 1 more multiplier. If you think you know what you're doing, pause the video and try that. So in the first multiplier, we'll convert the grams to moles of acetaminophen. Please, when you're showing your work, don't just put grams or moles. Label it like I'm doing there. Grams of acetaminophen and moles of acetaminophen. We'll do this using the molar mass, right? When you see grams and moles, that's the clue. We need to use the molar mass. 1 mole weighed 151.18 grams. Next, we can convert the moles of acetaminophen. We could use Avogadro's number, and we can find the molecules of acetaminophen, the number of particles of acetaminophen. Because acetaminophen is covalent, it's made up of these molecules, right? So 1 mole of acetaminophen has that huge number, Avogadro's number, 6.022 times 10 to the 23 molecules. And then finally, we just saw that the molecules of acetaminophen can be converted to atoms of any element that's in the molecule. In this case, atoms of oxygen, because we saw in the molecular formula or the molecular structure that there were 2 atoms of oxygen in every 1 molecule of acetaminophen. So now we have everything we need. We're going to keep 4 significant digits in the answer, and we're expecting a huge number, and sure enough it will be 1.213 times 10 to the power of 22 atoms of oxygen are in that sample. All right, so we just got through some other challenging questions. The first one was straightforward, converting moles to grams. You're going to do that a lot. The second one, we needed to find particles, in that case molecules. So that's where we had to also use Avogadro's number, 6.022 times 10 to the 23. In the third example, part F, we needed to go one step further and actually look at the molecular formula to use the ratio 2 atoms oxygen for every 1 molecule. This next question is a little bit easier. Pause the video and see if you can set it up yourself. So we have 500 grams of acetaminophen. How many moles are in there? Well, I know that the molar mass of acetaminophen is very close to 150 grams. That means a mole has a mass of pretty much 150 grams. It was 151.18. So just doing some mental math, if I've got 500 grams of acetaminophen, I definitely have more than 1 mole. In fact, I have a little bit more than 3 moles. So I'm expecting the answer to be a little bit bigger than 3. So let's see if we get that answer. Let's get rid of the grams of acetaminophen, and we'll switch it to moles of acetaminophen. I'm not sure if you've noticed my abbreviation of the word mole is MOL. Okay, that is the actual abbreviation we use for mole. We drop the E and just write MOL. So 1 mole using the molar mass, 151.18 grams, and we're done. 500 divided by 151.18, and we can keep 4 significant digits, 3.307 moles of acetaminophen. So just like I figured with my mental math, a little bit more than 3 moles. And the last question on the worksheet, if you had 5 grams, 5.000 grams of acetaminophen, what mass or how many grams of nitrogen are in that sample? Okay, so we know that there is nitrogen in the molecular formula for acetaminophen, so there has to be a certain mass of nitrogen in this 5 grams of acetaminophen. There are several ways to calculate this. Okay? Some that are easier than others. So let's do a harder way first. We could take the mass of acetaminophen that was given to us, and 99.9% of the time, if you're given a mass in stoichiometry, you're going to convert that to moles. So let's use the molar mass and switch the grams of acetaminophen to moles of acetaminophen. Now what could I do? 1 mole weighs 151.18 grams, the molar mass. Well, looking back at the chemical formula, you might remember when I was calculating the molar mass, I kept saying things like this. I said that there are 8 moles of carbon in 1 mole of acetaminophen, and that's why we wrote 8 times carbon's molar mass. We said there were 9 moles of hydrogen in 1 mole of acetaminophen, so 9 times 1.01. Notice every time I did that, if I said that there was 2 moles of oxygen in 1 mole of acetaminophen, well, that's a unit multiplier, isn't it? So 1 mole of nitrogen is in 1 mole of acetaminophen because the chemical formula has just 1 nitrogen in it. So 1 mole of nitrogen is in 1 mole of acetaminophen. So if we're trying to find the mass of nitrogen, why don't we convert the moles of acetaminophen into moles of nitrogen? The fact that there's 1 nitrogen in the formula tells me that there's 1 mole of nitrogen for every 1 mole of acetaminophen. Now that I have moles of nitrogen, we could use the molar mass of nitrogen to get rid of the moles and switch to grams of nitrogen, right? So a molar mass can always be used to convert moles of something to grams of that thing, or to convert grams of that thing to moles of that thing. So we converted up above grams of acetaminophen to moles of acetaminophen, and we used the molar mass of acetaminophen. If we have moles of nitrogen, we can convert that to grams of nitrogen, but we just need to use the molar mass of nitrogen. So 1 mole, we look on a periodic table, it weighs 14.01 grams. There's my answer. Keeping 4 significant digits, 4634 grams of nitrogen. But there's a faster way to have done this. If you did your percent composition earlier, you would have done for the percentage of nitrogen, if you showed your work, you would have said 14.01 grams divided by the total times 100. That would have given you 9.267% nitrogen. Okay, you would have calculated that earlier. And that's a percentage based on mass. So it means for every 100 grams of acetaminophen, there were 9.267 grams of nitrogen, right? So we could have used that down here. We could have said to ourselves that in 5.00 grams of acetaminophen, we could have got rid of the grams of acetaminophen and switched to grams of nitrogen because we had the percent composition already done. 9.267 grams of nitrogen for every 100 grams of acetaminophen. This is from the percent composition that we had done earlier. If you do that, you're going to get the same answer, 0.4634 grams of nitrogen. Okay? Either method works, either one would be acceptable on an assignment or a test. So there's not just one way to do some of these stoichiometry problems. These other questions we did, yes, that's the only way to do those things using unit multipliers. And here, though, we had more than one way to set it up. There's even more ways than what I've shown here, right? But any way where the units work out properly, and you've got access to the numbers on a periodic table, then you can set that up and legitimately find the answer. All right, so that was the acetaminophen worksheet. I hope that makes some sense to you. I want you to try next the Ritalin worksheet, which comes next. It's very similar to the one we just did. You'll start by writing the molecular formula of Ritalin, finding the molar mass. It asks for the percent composition only for oxygen, so you don't have to do all of the elements. And then there's some questions just like the ones we were doing for acetaminophen. Try to have that completed by, by Thursday's class. We have tests on Monday, Tuesday, Wednesday this week. So by Thursday's class, have this completed for then, and we'll take a look at the answers together. Hope that helped.